Everyone is good.
Yes, sir.
Krishna.
Good evening.
All right. Ronaldo, Said, Shikani.
Sir, can you hear my voice clearly?
Yes, I can hear your voice. Good evening. Did you guys complete the assignments?
Yes, sir.
Any doubts from that?
No, sir.
All right. Ronaldo, any doubts from the assignment? All right. Said, did you complete the assignments?
No, sir, I didn't do it.
Why not?
I didn't log in the app yet.
All right. Please complete the assignment till the next class. All right.
Sure, sir.
All right. In the last class, we did how to evaluate limits. We learned 3 methods. First was direct substitution, then factorization, and then rationalization. Right? With all three, everyone is clear about this? Direct substitution, factorization, and rationalization.
Yes, sir.
All right. So let's start with the question regarding rationalization. Then we'll move on to the next topic. Solve this question. Limit x tending to 0 under root a square plus x square minus under root a square minus x square upon x square. All right. Try to find this. Hello, Kulsum.
Hello, sir. Good evening.
Good evening. Did you complete the assignments?
Yes, sir.
Any doubts on that?
Yes, sir. I have a doubt. 1 minute. Sir, in the assignment 5, the question 12.
So actually, tell me the question. I'm not finding the assignment right now.
Okay.
Just read me out. Or you can solve this. Till then, I can find the assignment. Or you copy pasted this. Alright. This is also the NCERT question, right? So this is a very easy question. Don't worry. Please try to solve this first. After that, we can solve that doubt. All right. I hope you remember what we did in the last class. Direct substitution, factorization, rationalization of evaluating limits. Right?
Yes, sir.
So solve this. Then we can go to your doubt. Very simple question. Okay. All right, Krishna. Syed, what is 1 root a square? You can simplify that further, right?
Yes, sir.
Who else solved this? Ronaldo, Shikani, Kulsum. Ronaldo, have you solved this? Solve it. All right. I'll give you guys 2 more minutes for this. All right, let's see how to solve this. We have limit extending to 0, under root a square plus x square minus under root a square minus x square upon x square. We can multiply under root a plus x square plus under root a square minus x square. Right, everyone? You did this step, I hope. All right. So limit extending to 0. This is a minus b, a plus b. So that is a square minus b square. So I can write a square plus x square under roots minus a square minus x square under root square upon, same as it is in the denominator. All right. So limit extending to 0. This is a square plus x square minus a square plus x square, right? Because when the brackets are open, they will be like this: so x square under root a square plus x square plus under root a square minus x square, x a square and minus a square is cancelled. This is 2x square, right? This is 2x square. So x square and x square we can cancel. So finally we'll have limit extending to 0, 2 upon a square plus x square under root plus under root a square minus x square. Now put x equals to 0. This is a square under root, a square under root, 2a, 2 by 2a is 1 upon a. All right. Kulsum, Ronaldo, this is clear?
Yes, sir.
All right. Now let's come to your question. Differentiate x square minus 5x plus 8 into x cube plus 7x plus 9. All right, they are saying differentiate this with 3 conditions they are giving. In the first part, you have to solve using product rule. In the second part, they are saying you have to solve expanding the product. That means just open the brackets. In the third, they are saying use log and see if the answers are different. Right, Kulsum?
Yes.
So in the first one, why be this x square minus 5x plus 8, x square plus 7x plus 9. So let's differentiate dy by dx. Suppose this is u, this is v. Then you can use product rule. So this will be u v dash plus v u dash. So dy by dx will be equals to u or x square minus 5x plus 8 into v dash. What will be v dash? This is cube. Yes, 3x square plus 7. Right, Kulsum? Differentiation of x cube is 3x square plus 7x is 7
Yes, sir.
plus v is x cube plus 7x plus 9 into differentiation of this. This is 2x minus 5. All right. So we can open this brackets also, but let's stop that for a moment and try to solve the second part. But we have to open the brackets. So the second part is saying open the brackets. So just multiply. So if you multiply, you will get x square into x cube plus 7x plus 9 minus 5x into x cube plus 7x plus 9 plus 8 into x cube plus 7x plus 9. Now you have to differentiate this. So this is x raised to the power 5 plus 7x plus 7x cube plus 9x square minus 5x to the power 4 minus 35x square minus 45x plus 8x cube plus 56x plus 72. Yes or no, Kulsum?
Yes, sir, it's correct.
Alright. Now you can differentiate this very easily. And if you multiply and simplify this, you can see the answer will be same. All right.
Yes, I got it, sir.
And third one is using logarithm. So again, we have x square minus 5x plus 8 into x cube plus 7x plus 9. Let this be y. Now we can take log both sides. Log of y equals to log of x square minus 5x plus 8 x cube plus 7x plus 9. We have a property of log. If two functions are multiplied, then we can write as addition plus, right? This step is clear, Kulsum?
It's clear.
Log mn, we can write log m plus log n. Now we can differentiate this very easily. This is 1 upon y dy by dx equals to, this is 1 upon x square minus 5x plus 8, and differentiation of this is 2x minus 5 plus 1 upon 3x square plus x cube plus 7x plus 9 into 3x square plus 7. Take LCM and so on, you will get the almost same answer. All right, almost, not almost, we'll get the same answer. First multiply this y so that this will be getting cancelled, this will be getting cancelled. You don't have to take LCM. All right, you just have to do multiplication. All right.
Okay, sir.
All right, I hope this question is clear. Very simple, just the lengthy questions, not very difficult. So let's move on. The last method to evaluate limits is standard limits. And this is very important. This you have to know anyhow. First formula is limit extending to a, x raised to the power n minus a raised to the power n upon x minus a. Does anyone know what the formula for this is? This is n a raised to the power n minus 1. All right, for an example, if you have limit extending to 3, you have x cube minus 3 cube upon x minus 3. Let's use direct substitution. So we can put x equals to 3 here. So 3 cube minus 3 cube is 0, 3 minus 3 is 0. So we cannot do that. All right. You can use factorization here also, a cube minus b cube, but if it was 4 or 5, then we could not. Let's make it 5, x raised to the power 5, 3 raised to the power 5. Now we cannot use factorization even. So what we can do, you can use the formula directly. All right, x raised to the power n, a raised to the power n. So here x is x, a is 3, n is 5. So the formula for this is n a raised to the power n minus 1. So 5, 3 raised to the power 5 minus 1 is 4. So 5 into 81. So this is 405. All right. Is it clear, everyone?
Yes, sir.
All right, Syed, Kulsum, Ronaldo. All right,
Yes,
note
sir.
it down. Note it down. I'll give you a question on this. All right, this is the first question. Hello, Ishan.
Hello, sir.
You are late today also.
Yes, sorry, sir.
All right. Did you complete the assignments?
No, sir.
No. You have not completed any assignments, I guess.
Sir, I just received the assignments from about last class when the team told me how to access them. Before that, I told you that I could not access any assignment.
Right. All right. So no worries. Please complete that. Try to complete that by next class or by next week. All right. Because differentiation
Yes, sir,
part
I
is
will try.
very important. All right.
Sir, because I'm not at my home right now. That's why it's a little bit harder to attend classes and I'm facing lots of network issues as well.
Mhm. No worries. No worries. Try to do as much as you can. All right. All right, Krishna. Ronaldo, you got 12.3 into 10 to the power 27. How do you have that answer? This is not 10 to the power 24. This is 1024. All right. All right, Ronaldo. Ishan, Kulsum, have you solved this? Said, all right, take 2 more minutes. All right, let's see how we can solve this. Kulsum, have you solved this?
I'm solving it.
All right. The only time taking process in this is factorizing this, I guess. 2 to the power how much? But if you use, like, you should not do this, but sometimes it is okay because you already know this is based on this formula. So if this is x raised to the power n, then this must be 2 raised to the power 10, right? We can like use this trick, and this is x minus 2. All right. So here n is 10, a is 2. So the answer will be 10 into 2 raised to the power 10 minus 1 is 9. So if 2 raised to the power 10 is this, then 2 raised to the power 9 will be half of that. So 512, so 5120 will be the answer. All right, everyone is correct about this. Kulsum, this is clear.
Yes, sir.
Next question. Limit extending to 2, x raised to the power 10 minus 1024 upon x raised to the power 5 minus 32. Try to solve this one. All right, Kulsum. All right, let's see how we can solve this. This is limit x tending to 2. This is x raised to the power 10 upon 2 raised to the power 10 upon x raised to the power 5 minus 2 raised to the power 5. Now, to use that standard form, we have to have x minus 2 in the denominator of this and x minus 2 in the denominator of this. So what we can do, we can divide this by x minus 2 and this by x minus 2, right? Because we did not do anything, we just divided and multiplied the same thing. All right, Ronaldo, clear? So now this is we can say now this is limit extending to 2. So just solve this this one is 5 1 2, or we can say 10 into 2 raised to the 9, and this will be 5 into 2 raised to the power 4. So we can cancel things out. So this is 2 into 2 raised to the power 5. So 2 raised to the power 6, which is 64. I hope this is clear to everyone. Said, this is clear.
Yes, sir.
Ishan. Alright, Ishan is not in the class. Shikani, this is clear. You are not responding in the class at all.
Yes, sir.
No. So if I say this, then you respond, right? Otherwise, you don't. Some more standard limits we have. If theta is in radians, then we can say limit x tending to theta tending to 0 sine theta. We can use direct substitution here. If theta is tending to 0, then sine 0 will be what value? Give me 1
0.
moment. Yes. Who said 0? Someone said 0.
Krishna, sir.
All right. So theta is tending to 0. That means sine theta will be 0. So this answer is 0. This is the first one. Second one, if theta is tending to 0, then cos theta will be
1.
1. Absolutely right. Limit theta tending to 0 sine theta by theta. Does anyone know what this value is?
1.
1. Limit theta tending to 0 tan theta by theta.
So also 1.
Also 1. Absolutely right. So these are standard limits you have to know. And in this case, you have to notice that if sine has an angle in it and it is divided by the same angle, then the answer is 1. If the angle is tending to 0. All right. So please note this down. Done, everyone?
Done, sir.
All right. Let's solve these questions. Limit x tending to 0, sine 3x upon x. Second one is limit x tending to 0, sine 5x upon 2x. Third one is limit x tending to 0, sine px upon sine bx. All right. Try to solve this one. All right, Ronaldo. Correct answer. All right, let me solve the first one. So we can write this limit x tend to 0. If sine 3x is in the formula, we have to divide by the same angle in the sine. So this sine has 3x. So we must have 3x in here. To make 3x, I can divide by 3 and multiply by 3. So this limit will become 1. So the answer is 3. This thing is clear? Everyone?
Yes, sir.
All right, Kulsum, Said.
Yes, sir. Got the answer.
Try to find the next two. We'll solve the next question. Ronaldo, correct answer. Is everyone solving this or not? Absolutely right. Said. Krishna, that is the wrong answer. See, we have limit extending to 0 sine of 5x. So what angle do we want in the denominator, Krishna?
5x.
5x. So let's just write 5x. So if I divide by 5x, then I have to multiply with 5x also. Yes or no?
Yes.
And in the denominator, we have 2x as it is, because we cannot just like make it invisible. So that is 2x is there, and we wanted 5x, so we divided by 5x, multiplied by 5x. So this masala here becomes 1. This x and x is getting cancelled. So the answer is 5/2. All right.
Yes, sir.
Same thing, please try in the third part. Kulsum, this is clear?
Yes, sir.
Please try in third part. All right, we got 3-4 answers. Krishna, you did not solve this?
Sir, I have sent the answer.
You have sent. Yes, you have sent. Saeed has not solved this.
Yes, sir, I'm doing. See, this is limit extend to 0. Saeed, what do we want in the denominator of this? Sine a raised to sine ax. So AX.
Ax. So let's just multiply and divide by ax. And what do we want in the denominator of sine bx?
So BX.
So bx and bx. So this becomes 1, this becomes 1, x and x are cancelled. So the answer is a by b. All right. This is clear.
Yes, sir.
All right. Next formulas are last 3 formulas for this. if you have limit x tending to 0, e raised to the power x minus 1 upon x. If you put x equals to 0, then e raised to the power 0 is 1, 1 minus 1 is 0, 0 upon 0 is not defined. And this answer is log a. All right, this is base e, natural log we are talking about. All right. If we have limit x tending to 0, e raised to the power x minus 1 upon x, can anyone tell me what the answer will be here? What will be the answer here?
So log base 10.
No. See, what did we change? We just changed this constant to this constant. So if this is log a, then this will be log e. Yes or no?
Yes,
There's
sir.
no difference, just the constant is changed. And this answer is 1, right? Log e base e is 1. Limit x tending to 0, log 1 plus x base e upon x is also 1. Note it down.
Done, sir.
All right. So this is the way to evaluate limits. Now question arises, when does limit exist, when not? So if somebody asks you, find if limit exists or not, and what we say, if LHL equals to RHL, I hope you remember this. This is left hand side limit. This is right hand side limit. Then we say limit exists. All right. How to find LHL? You always have to put limit h tending to 0, f of a minus h. What is a? The point where we are finding limit. All right. This is LHL. And RHL is limit h tending to 0, f of a plus h. All right. H is a very small positive number. All right. Please note this down too. We'll see how to apply this in a question. You guys remember this, right? LHL, RHL, or should I explain this again? Saeed, Kulsum?
No need, sir.
No need. All right. Ronaldo? Ishan, Shigani? All right. Note it down. The question says, check that the limit f of x extending to 1 exists or not. F of x is 1 plus x square, 2 minus x, 0 less than equals to x less than equals to 1. x is more than 1. All right. Write this question down. Don't try to solve it. I'll solve this. Done, everyone?
Done, sir.
All right. So let's find LHL. If somebody asks if limit exists or not, then LHL should be equals to RHL, then limit exists. So what is LHL? LHL will be limit x tending to 1 minus, we are checking at 1. So 1 minus means a number that is slightly less than 1, right? This is 1 in the number line. We are moving to the left side. So any number that is slightly less than 1 is represented by 1 minus, left hand side limit. All right. And the function is f of x. So in this function, it is broken down into two parts, this and this. So what part shall we take as f of x? Or which function should we take as f of x? 1 plus x square.
1 plus x square.
Absolutely right. Because when this is smaller than 1, then this is the function. And we are checking the left hand side limit. So x is smaller than 1. So the function will be 1 plus x square. And I told you when finding the left hand side limit, always put x equals to 1 minus h. So this becomes limit h tending to 0, 1 plus 1 minus h square. This step is clear or not?
Yes, sir.
All right. So this is equals to limit h tending to 0, 1 plus 1 plus h square minus 2h. Now we can directly put h equals to 0, no issues. No one is becoming infinite. So the answer is 2. This is for LHL. I hope this part is clear. Everyone?
Yes, sir.
All right. So let's try to find RHL. This is limit extending to 1 plus. 1 plus means we are moving from the right hand side. That is why this is called RHL, right hand side limit. And f of x. So here, what will be f of x?
2 minus x.
2 minus. Should we put x equals to? X equals to, we can put 1 plus h. All right. On the right hand side limit, always put x equals to 1 plus h. On the left, 1 minus h. So this we can write limit h tending to 0, and this is 2 minus, on the place of x, 1 plus h. All right.
Yes,
So
sir.
this is equals to limit h tending to 0, 2 minus 1 minus h. Now we can put directly h equals to 0. So the answer is 1. So LHL is not equals to RHL. So limit does not exist. Is this question clear to everyone or not?
Clear, sir.
All right. Syed, Kulsum, Shikhani, Ishan.
Yes, sir. Clear.
All right. Rest of you guys. Ishan, this is clear?
Yes.
All right. Please note it down. This is your question. Try to solve this. Send the answer in the chat.
That's
All right, everyone solve this.
Yes, sir.
All right. Ronaldo solved. So limit exist or not?
It does not exist.
All right. Just a minute. All right. LHL, we can write limit extending to 0. Yes, 0 minus 2x plus 3. So putting x equals to 0 minus h. So minus h. This will be limit h tending to 0 to 0 minus h plus 3. So this is limit h tending to 0, 0 minus 2h plus 3. So we can put h equals to 0. This becomes 0. The answer is 3. Right? This is clear to everyone? Yes or no?
Yes, sir.
RHL. Limit extending to 0 plus 3 into x plus 1. So putting x equals to 0 plus h. Limit h tending to 0, 3, 0 plus h plus 1. And this is equals to limit h tending to 0. This is 0 plus 3h plus 3. And this is also 3. So I think limit exists. Krishna?
So we should substitute 1 plus h, right?
No, we are finding at x equals to 0, right? Limit at 0. So here a is 0, right?
Okay, sir.
So you have to substitute with the value which we are finding the limit at. All right. If you are finding at 3, then 3 plus h. Right. Why we are doing this? Why replacing the value? Suppose we are finding the limit at 3. So if I write 3 minus h, and h is a positive quantity, that means x is slightly less than 3, right? That is what we're trying to find. And if we put x equals to 3 plus h, that means just a little bit more than 3. So this is RHL, this is LHL. Clear, Krishna?
Yes, sir.
All right, Kulsum, Said.
Yes, sir.
Yes, sir.
All right, Ishan, clear?
Yes, sir.
All right. So next question. F of x equals to 2 minus x and 2 plus x. X is greater than or equal to 0. X is less than 0. Check whether the limit f of x extending to 0 exists or not.
Done, sir.
Right. Let's see. LHL equals to limit extending to 0 minus 2 minus x, putting x equals to 0 minus h. This is limit h tending to 0, 2 minus 0 minus h. So put h equals to 0. So this is 0. So the answer is 2. Right? RHL limit extending to 0 plus 2 plus x, putting x equals to 0 plus h. So this is limit h tending to 0, 2 plus is h. So this is again 2. So yes, LHL equals to RHL. So limit exists and limit extending to 0 f of x is the value is 2. All right. If both are equal, then the limiting value is the value of either of them. All right. I hope this is clear, everyone.
Yes, sir.
All right. Next question. or let's just do this continuity. What is continuity? It's clear, right? How to find limit, how to evaluate this. Everyone is clear about this?
Yes, sir.
The first one, we have to take the function 2 plus x. Did I do something? Let's see. Oh, my bad. Yes, this is RHL. Nobody even mentioned this. This is LHL. But then we have to this minus. This is minus. This is minus. Why? Because we have x is less than 0. So the function is this, right? On the LHL, we have to take 2 plus x. This actually is written in the inverse order. So my bad. All right. Correct, Ronaldo. Absolutely correct. On the LHL, you have to take 2 plus x. All right. Everyone, did we
Yes, sir.
all wrong, or you did not even notice this, or you did not want to say this? What is happening? Krishna,
Sir, I wrote it correct in my book.
then why didn't you tell me that, sir, you thought like this is the wrong thing?
Sir, I didn't get the idea, sir.
I did not get the idea. Okay, Said, what about you?
So I did not notice.
You did not notice. Nice. All right. No worries. So this is LHL, this is RHL, and change accordingly. This will be plus, plus. Oh, sorry, this is minus, this is plus, this is plus. All right. So what is continuity? Till now, we studied limit. That if graph is broken somewhere or not existent in some point, then what value is it tending? Now, what is continuity? If you can trace the whole graph without lifting your pencil or pen, then the graph is continuous. As simple as that. All right. Or in official terms, if there is some breaking points, like if there is an open circle here, if I draw another graph like this, open circle this, then this is discontinuous, right? To draw this graph, you have to lift your pencil. This is clear? What is continuous and not continuous?
Yes, sir.
All right. So as simple as that, what is continuous? If we can trace the graph of a function without lifting the pencil, then graph is continuous. All right, note it down just to make you revise for the revision. All right, done.
Done, sir.
So how to find continuity at a point? The function is said to be continuous at a point A in its domain. if limit extending to a f of x equals to f of a. All right, what this means, that limit exists at a, first of all, that is the case, and the value of limit is equals to the value of function at f of a. What this means, if I draw a graph, suppose this point is 4 and this is 4, this is 5, then if you find limit, this is open circle, all right, if you find the limiting value, limit x tending to find 5 f of x, then the answer will be 4, right? The left hand side is 4 and the right hand side is 4. But if you find f of 5, then graph is not existent and this is not continuous. But if f of 5 is also 4, then this will be continuous. All right, just find f of a and limit extending to a. If both are equal, then we can say graph is continuous. This is clear, everyone?
Yes, sir.
All right, note this down too. Done, everyone?
Done, sir.
If function fails to be continuous at x equals to a for any of the following reasons. These are the reasons how to check the continuity where the function fails to be continuous. First reason, limit exists at a but is not equal to f of a. What this means, graphically, if I draw a graph like this, there is open circle here, and at this point the graph's value is this. Suppose this line is again x equals to 5 and this point is 4, this point is 6. All right, can anyone tell me, if this is function f of x, then limit f of x extending to 5, what is the value here, the limiting value? Look at the graph and think.
4.
This 4, absolutely right. What does limit say? The neighborhood, right? This is 4, this is 4, so limiting value is 4. And what is f of 5? What is f of 5?
6.
6, right? Because when you put x equals to 5, the graph is here, above the most of the graph. So to draw this graph, I have to go like this, pick up my pencil like this, then again like this. I have to pick the pencil, right? I cannot draw this without lifting up the pencil. So this is not continuous. Why? Because these two are not equal. Is this clear or not, everyone?
Yes, sir.
All right, Sayed, Kulsum, Ishan.
Yes, sir.
All right. What is the second condition? Limit does not exist at x equals to a. It may be the case that the limit itself is not there. This is x equals to 5. This is 4. This is 6. All right. So here LHL, can anyone tell me what is the value of LHL at x equals to 5?
4.
4. Because slightly lesser than 5, if you move, then the graph will be 4. And RHL, limit extending to 5 plus f of x. What is RHL? 6. Absolutely right. So LHL is not equals to RHL in this function. So we can easily see that the graph is not continuous. The limit itself is not defined, then how can we say that limit is equal to f of a? Right, everyone, is this clear or not?
So how RHL is 6?
See, slightly more than 5. So if you move slightly more than 5 and find the value of y, then this value is 6, right? This is 5. If you go to the right side, then the graph is here at 6. If you move a little bit left, then the graph is here, it is 4. Yes, Krishna?
Yes, sir. Clear.
All right. Please note it down, everyone.
Done, sir.
Everyone done? Ronaldo, Syed, Kulsum.
Yes, sir. Done.
All right. What third condition? There is a third condition also, in which f of a does not exist. The value is not there in this function. So what this means, if I draw a graph like this, all right. So at x equals to 5, there is no graph, right? It's blank, open circle. But if you find limit, then it may be 4. If you move slightly less than 5, then the graph is there, which is 4. If you slightly move right to the side, and the graph is there, which is 4. So limit exists and is 4, but the graph is not there at 5. So f of 5 is not defined. Then we can say the graph is discontinuous. All right. Very simple. Note it down. All right. This is the question. All right. We have to show that the function f of x given by this is continuous at x equals to 0. And the function defined as sin x upon x plus cos x when x is not equal to 0, and 2 when x is equal to 0. All right. We have to find the continuity at x equals to 0. So first thing we have to find f of a, and what is a here? 0. And then we have to find limit x tending to 0 f of x. All right. We don't have to find LHL RHL here. Why? Because we can easily see that LHL and RHL both are equal, right? Same function is given. This is clear, everyone?
Yes.
Please try to solve this. I'll give you a few minutes. All right, Krishna. Let's see. Who else solved this? Ronaldo? Syed, Kulsum, Ishan, Shikani. All right. So let's try to find f of 0. F of 0 is 2 because they have given that if x is 0, then the function is 2. This is very simple. Second step, limit x tending to 0, f of x. So what will be function here? This or this? All right, Krishna. Which function shall we choose? This or this? First or second?
Second.
Why the second one, Krishna?
Oh, sorry, sir.
Because
It's first one.
first, right? Because x is never equals to 0 here. If this is tending to 0. Sin x upon x plus cos x. So we can break down this. This is sin x upon x tending to 0 plus limit x tending to 0 cos x. So we have already seen this. Sin x upon x is 1 plus cos 0 is 1. So the answer is 2. So limit equals to f of a. So function is continuous. Is this clear or not to everyone?
Yes, sir.
All right, this is not very difficult topic. Kulsum Syed, this is clear.
Yes, sir.
All right. Next question. Let's make it exam. Examine the function f of t given by f of t equals to cos t upon pi by 2 minus t when t is not equals to pi by 2 and 1 when t is equals to pi by 2. Continuity at t equals to pi by 2. Let's solve this by yourself. I'll give you a few minutes. Has anyone solved this?
So what is cos theta by theta?
No, there is no formula for that. Let me tell you how to solve this limit question. So first, f of pi by 2, and this will be equals to
1.
1. So next, we want to find limit x tending to pi by 2 f of x. And the function here is cos t. That's this is t tending to this. All right. So the function is limit t tending to pi by 2 cos t upon pi by 2 minus t. So what we can do here, we can put t equals to pi by 2 plus h. How did I know this? Because in most of the general form, the way to do is something tending to 0. So if this has to tend to 0, then t minus pi by 2 has to tend to 0. And we know that if you replace the value, then we get h equals to 0. And we can say t minus pi by 2 is equals to h. So t will be equals to pi by 2 plus h. Is this clear or not? I don't think so.
No, sir.
All right. See, this is, can I write, if don't never take this, suppose I write this, all right, and I take this to this side, then t minus pi by 2 tending to 0, right?
Yes, sir.
And in the LHL, RHL, we saw that we replace the value of x, then we in the limit becomes h tending to 0, right?
Yes.
So can I say this and h will be equal because this is also tending to 0, and in limits we finally get h tending to 0 after replacing the value, right?
Yes, sir.
So can I say t minus pi by 2 is equals to h? So t will be equals to pi by 2 plus h. Yes or no?
Yes.
So now this is clear.
Yes, sir.
So we have to replace t equals to pi by 2 plus h. So we have to change the limits also. If we are replacing value of t, then we have to change the limit also. So when t, we are replacing the value t equals to pi by 2 plus h. So when t is tending to pi by 2, what will be the value of h? When t is tending towards pi by 2, then h will tend towards
0.
0, right? Ronaldo, not 1, because when t is almost equals to pi by 2, that means h is meaningless, that is 0. All right. So h tending to 0, cos of pi by 2 plus h upon pi by 2 minus pi by 2 plus h. All right. Now limit h tending to 0. What is cos 90 plus theta? Cos 90 plus theta
Minus sin theta.
minus sin theta. So minus sin theta. In the denominator, we get pi by 2 minus pi by 2 is cancelled, minus h. Minus minus becomes plus. So limit h tending to 0, sine, this is h, sine h upon h, and this is 1, right? This is the formula. So we get limit is equals to f of pi by 2. That means limit t tending to pi by 2 f of x is equals to f of pi by 2. So continuous at pi by 2. I hope this is clear, everyone.
Yes, sir.
All right. Kulsum, Said, Ishan, Shikani.
Yes, sir.
Sir, in which case we should substitute this manner?
Whenever you see that this value is not tending to 0, all right, except in that case, in that formula, when x raised to the power n e raised to the power n, that value is tending to a, this thing. All right.
Okay, sir.
Please note it down. All right. And this is all for today's class, guys. I hope everything is clear about today's class. All clear today's class?
Yes, sir.
All right. In the next class, there will be an exam test of differentiation part. So please revise accordingly. All right. And complete the assignments also. If you have noted this down, then you can leave. This is all for today's class. Take care, guys.
Thank you, sir.
All right.
Thank you, sir.
All right.
Thank you, sir.
All right. All right, Ronaldo.